Chapter 8, Section 3 is solving right triangles. And the first example asks us to use the trig ratio. Cosine is 24 over 25 to determine which angle of the triangle is angle A. So what I would do first of all is I would take 24 and divide it by 25, and that tells us that the cosine of A is 0.96. Well, cosine is adjacent over hypotenuse. So if we do the cosine of angle 2, we would have 4.8 over 5, adjacent over hypotenuse. And if we do the cosine of 1, we would have adjacent over hypotenuse, which is 1.4 over 5. And what we can do is divide those two things and see which one ends up being 0.96. So I'm going to start with angle 1. 1.4 divided by 5 is 0.28. It's not 0.96. And then 4.8 divided by 5 is 0.96. So if the cosine is 24 over 25, we are talking about angle 2. So our answer, I'll write it over here, is angle 2. So we just looked at the two different possibilities, adjacent over hypotenuse, and see which one equaled the number they gave us. The next example, same thing. We're trying to figure out which one is angle A. First one is 8 over 17. So if we do 8 divided by 17, that equals 0.4705. Well, if we are talking angle 1, sine of angle 1 is opposite over hypotenuse, which would be 27 over 30.6. And the sine of angle 2 will be opposite over hypotenuse, which is 14.4 over 30.6. And if we divide those, 27 divided by 30.6 is 0.88. 14.4 divided by 30.6 is that 0.4705. So the first one here matches up with angle 2. And then we have tangent of A is 1.875. If we do the tangent of 1, you will have 27 over 14.4. And if you have the tangent of angle 2, opposite over adjacent, is 14.4 over 27. Some of you should be able to look at this and tell me which one is the number that's bigger than 1. And that's going to be the 27 divided by 14.4. And if you can divide that out, you see it's 1.875. So in the second one, we are talking about angle 1. The next example is very similar. Sine is 3 over 5. Sine is the SOH, S-O-H. Opposite over hypotenuse. If this is the opposite side, then the angle that we're talking about is angle 2. And letter B, tangent of A equals 5/3. Tangent of A is the TOA. So we want opposite over adjacent. And if angle 5 is the opposite side, then we are once again looking at angle 2. The next thing we're going to look at is inverse trig functions. It says if the sine of A equals x, then the inverse sine of x equals angle A. And what this means, in the last section, we typed into our calculator sine of 30, and it gave us a bunch of decimals. Now we're doing this backwards. They're going to give us the decimals, and we're going to come up with the angles. And we can do that inverse sine, inverse cosine, and inverse tangent. The first one they ask us to do is the inverse cosine of 0.87. You hit the second key, and then cosine, and then enter 0.87. And when you do that, you end up with 29.5. We're asked to find the angle to the nearest degree, so that would be a 30-degree angle. The next one is inverse sine, so we do second and then sine, 0.85, and that ends up being 58.2, so that is a 58-degree angle. And the third one, we do second tangent, 0.71. That comes up with 35.37, so that is a 35-degree angle. And the last three, inverse tangent, 0.75, ends up being 36.8, so that is 37 degrees. Inverse cosine of 0.05 ends up being 87 degrees. And inverse sine of 0.67 is right about 42 degrees. On our second page, we are asked to find all of the unknown measures. And in this case, we have three unknown measures. We are asked to find EF, we are asked to find DF, and we are asked to find angle D. And I'm going to find angle D first of all. This is a right triangle. This is 90 degrees. These two angles together add up to 90. So I can do 90 minus 58, and angle D is 32 degrees. To find EF, if we know this angle, this is the opposite side and the adjacent side. Opposite over adjacent is tangent. So we can do tangent of 58 equals 14 over x. And to solve that, we're going to switch places with those two, and you have x equals 14 divided by the tangent of 58, and 14 divided by the tangent of 58, I'm going to call that 8.75. To find DF, you can do this a couple ways. Now that we know that side is 8.75, we can use sine or cosine. Or if you prefer, you could do your Pythagorean theorem. 14 squared plus 8.75 squared equals x squared. I'm going to use sine, and I'm going to say the sine of 58 equals 14 over h. Sine is opposite over hypotenuse. And we switch these two around, and that becomes h equals 14 over the sine of 58. 14 divided by the sine of 58 is 16.5. So I've found all three missing measures. In the next example, you will notice we are not given any angle measures. So the first thing I'm going to do is find angle T. We know the opposite side and the hypotenuse, so we can say the sine of angle T is 5 over 5.7. And if we do 5 divided by 5.7 is 0.877. Well, now if we want that angle, we're going to do the inverse sine. If we know the decimals and we want the angle measure, we do the inverse sine. So I do second sine 0.877, and that ends up being 61 degrees. Well, if angle T is 61 degrees, we can figure out angle R. Angle R is going to be 90 minus 61, which is 29 degrees. And then to figure out this missing side, I'm going to do tangent of 61. Actually, I'm sorry, I'm going to do cosine. Cosine of 61 equals adjacent over hypotenuse. Cosine of 61 is adjacent over hypotenuse. And then I can do 5.7 times the cosine of 61. And that side ends up being 2.76. So we figured out all three missing links. The last two we need to do some graphing. P is negative 3, 3. So negative 3, 3, which is P. Q is the ordered pair 2, 3. So we go 2 to the right and up 3. And R is negative 3, negative 4. So we graph those 3 points, and from those 3 points we graph that triangle. Now 3 of these are pretty easy to figure out. Angle P is our right angle, so that's 90. PQ we can just count off. 1, 2, 3, 4, 5. So PQ is 5. PR is 1, 2, 3, 4, 5, 6, 7. To figure out QR, we can do the Pythagorean theorem. 5 squared plus 7 squared. And then I'm going to square root that. And QR ends up being 8.6. Now PQ was 5 and PR was 7. So I'm going to find angle R first. This is the opposite side. This is the adjacent side. So we're going to write out the tangent of R equals 5 over 7. 5 divided by 7 is 0.714, and that's when we do the inverse tangent of 0.714, and that angle ends up being 35.5. Let's call it 36. Well, if angle R is 36 degrees, angle Q is 90 minus 36. So angle Q will be 54 degrees. And we found all of the side lengths and all of the angle measures. Now right down here where I did 5 divided by 7 and came up with 0.714, some of you are going to get to the point where you don't have to do that. You could do it all in one step, and you could do the inverse tangent of 5/7, and that would get you the answer in one step. And the last example for RST, we're going to do -3, 5, which is R, 4, 5, over 4 and up 5, which is S, and then 4, -2, which is T. Oops. So we have 3 that are fairly easy. S is your right angle, which is 90 degrees. R to S we can count off. 1, 2, 3, 4, 5, 6, 7. ST, 1, 2, 3, 4, 5, 6, 7. RT, we can use Pythagorean theorem. Let me double check those. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So Pythagorean theorem, 7 squared plus 7 squared. Square root that. 9.89. I'm going to round it to 9.9. Some of you might recognize that as a special right triangle, and the ratio of the sides is 1, 1, square root of 2. So that could also be 7 square root of 2. And to find this angle measure, we would do the inverse tangent. Tangent is opposite over adjacent, so 7 over 7. And if you do the inverse tangent, 7 divided by 7, that is a 45-degree angle, which makes angle T a 45-degree angle.